1 2 1 2 3. 1 2 1 2 3. 1 2 1 2 3. 1 2 1 2 3 1 2 3. 1 2 1 2 3. 1 2 3. Alright, seems like this is working now. So this stream is going to be about answering a question that comes up. So Ireland now has well over a gigawatt of solar panels installed, and the question arises, at what point does that start to have a big impact on electricity prices in the middle of the day? When will we see the prices drop effectively around towards zero at some point during the summer months? And I just want to see if we're already starting to see around the very middle of the day, if that's already causing some spells or at least an impact where maybe it's not going towards zero, but it's already cutting into the prices around noon. So let's get started. The first thing to do in this analysis, I'm going to go to kilowatt.ie, because over here we can go to wholesale electricity prices and we can download that data. Save and replace. Now I already have this downloaded, so that's just to show you how it goes. That's the file, and this is my R script. So as you can see, I have made a little start on this already, but not much. So let's get into it. Here we go. So I'm going to start off by reading this CSV file with the electricity prices into R, and I'll just show you how it looks. So we go ahead and we see it runs from October 2018, and this price is priced in euros per megawatt hour. And now let's just get the formats correct. Very important here is to include time zone if you happen to not be located in that time zone yourself, because your computer will assume that you want whatever time zone you're located in, but this data needs to be for Ireland, Irish time zone. Okay, so so the way I'm going to try and answer this question is I want to make a graphic of electricity prices by hour of the day, and I want to do it during the summer months for each year. So we're going to have the summer months of 2018, 2019, 2020, etc., with a kind of a bar chart. And I want to see if there's a progression where in the latest year or two, especially 2024, we start to see a a dip around 1 p.m. ish, if that is starting to emerge. And also take some general looks at the prices by hour of the day. I think this could be, there are all sorts of interesting questions that we could look at. So what I've done here is this here variable, or this object, is it's a subset of the electricity price data, just looking at 2024 from May until the end of July, so 3 months of astronomical summer. So what I want to do is make a version for the other years, so 2023, 2022, 2021, and 2020, and also 2019. Oh, okay. So now this needs to say 2023 to 1 0 2019. Three, 2, 1 0. What did I do wrong? 2024, 2023, 2022, 2021, 2020, 2019. And of course, there was a crazy increase in electricity prices from, I think, centered around 2022. That could certainly affect things. But we should be able to look back at 2019, which was kind of a normal year. And we should also be able to, even if all the prices are elevated, we still can look at the relationship between the 11 p.m. price and the 11 a.m. price. And that ratio shouldn't be as screwed up as other things by the gas price increases of those years. Okay. So let's just, before we really get into the meat of it, let's look at the means. And I'm going to put in a comment here, keep my code kind of half tidy. Also up the top, that should have a comment. Load and prepare data, and down here we should have a comment that says subset, or what should we say, extract somewhere. So if you're not so familiar with solar energy, Ireland is a long way up from the equator. I think it's around 53 degrees north. So there's a strong seasonality. You will have drastically multiple times higher solar PV energy output during the summer months than the winter. So yeah, not much point looking at what solar does to electricity prices during February. That is going to, any signal there is going to get washed over with noise. I believe, certainly in a simple analysis like this. So just to see exactly what we're dealing with in terms of the general differences between these year by year, let's look at the mean prices. So this year, last year, about the same. Year before, substantially higher. 2021, about the same as this year. 2020, whoa, look how cheap that was. A quarter of current prices in 2020, and 2019 half of the current prices. So yeah. Okay, regardless, at least we still have, I think that 2021 is a good reference point. That's There wasn't too much solar at that point, and the prices were about the same as current. Okay, that could be our key comparison. Okay, so now we're getting to the kind of more tricky bit, which is we need to prepare the data to make some sort of a graph. So let's look at the data one more time. So we have hour by hour price data here. Yeah, so we need to create a new, or at least one way to do this would be to create a new variable, or a new column, I should say. Let's call it hour. And I'm going to create it up here so that I don't have to do it 6 times. I'll create it here and rerun everything. Yeah, I suppose this is still part of load and prepare the data equals. Yeah, so let's do it like this. I'll substring this. And just call that hour 22. Yeah. As numeric ELE dollar date. No, substring. So I'm going to take the first 2 characters of this here, like 22. I'm going to, yeah, so from 1 to 2 and make that numeric, and let's see if it worked. So head is a nice little R function to print out the first usually 5 rows or items. Yeah, that worked. Or if you put in another number after, it'll be a different number. Oh, that didn't work. How did it get 20 in each of these cases? As numeric substring ELE dollar date 1 2 is always 20. Head ELE dollar date. Oh, of course, it's taking, these are the first 2. So, right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I think we need 12 and 13. Okay, let's go head ELE NA 0, 0. Why is that NA? This seems to have worked, as does this. This didn't work. 0, 1 becomes 1, 0, 2 becomes 2. That's okay. But 0, 0 as, just run a little test if we can diagnose this. So that seems to work when you take, it's not a problem with doing an as a numeric on 0. What is the problem here then? Let's let's just do the first part. Is this telling us that these... Let's run this again. Okay. ELE dollar date 3. Ah, okay. We need to change it to a character first so that it doesn't, when it's bang on midnight, it just gives the date. So yeah, let's go as the character ELE dollar date and take the third item. Still doesn't work. So what we need to do is format that as year, month, day. Let's do that much first. Wrangling data is very annoying. So I have another file here that I have just give me a moment. I did some work on something else and I have another R file which I can take. There we go. Right. So this is some code. That's a line of code I used somewhere else. And let's see if it works for our purposes here. ELE dollar date. Yeah, that seems to have done it. Do we even need as.character? I'm not sure. Let's try here. There we go. Now we've got the zeros. Okay. Yeah, I love R. It's a great programming language, but it's probably not really R's fault. Dates and times are just a pain in general to work with as a type of data. Okay, so where were we? We are now ready to analyze by hour. So I think we can go right ahead and make a ggplot. So for those of you who are unfamiliar with R, ggplot is perhaps the most used library. That's an extra bundle of code that you can use. There is no, oh yeah, ggplot2 is what the package is called. And it's kind of strange the way it works if you're new to it. The code doesn't look like other R code really, but when you do get used to it after a while, it's very powerful and can even start to become intuitive eventually. Mapping equals AES, So this is going to be on the x-axis, we're going to have hour, and on the y-axis we're going to have price. And now we're going to have a geom bar, I think. We've already specified the data and the mapping. Now we want to go stat equals function of y. And then the function of y is going to be I remember I did this for some other code that I was writing recently. So I do have that on my computer somewhere. But you know what? It's easier just to Google it again. So let's go geom bar mean of y. Someone 2015 says that this thing has been deprecated, so but it worked for me recently. And I do keep R reasonably up to date on my system. Position equals dodge, stat equals summary. That's it. Okay. That's how we do it. Okay. Now, close my eyes and hope this works. Ignoring unknown parameters. How did he do this? Geom bar AES label x2 as factor, grips position dodge stat summary fun y. Object error not found. Oh yeah. So yeah, we need to run all this again. There it is. Wow. Okay. Not particularly difficult. I've only been at this for 22 minutes and it looks like we're getting close to having some results. That's quite ugly. But let's not worry about that for a moment. Data mapping. So what do we see here? We see a peak at 5, 6, 7 a.m. Really? Another peak at 8, 7 p.m. That one makes sense. 7 until 8, I suppose, technically speaking. And when's the trough? 10, 11, 12, 1 p.m. 10, 11, 12. From 1 p.m. until 3 p.m. That does line up with solar PV. Wow. Okay. No. No summary function supplied. So it's ignoring this here part, and it seems to be guessing itself to do mean. I would like that warning to go away. Unquote mean. Okay. So instead of fun.y, we just need fun and unquote this. Let's see if it works. Oh yes, lovely, beautiful. Now, these technically could be shifted, but I'm not going to spend the time to do that on stream right now. Okay, copy this and let's see if we can do the same for 2020. Let's not think about it too much. Just run through a couple of different years. 2022. 2021. 2020. And 2019. Now we can run all of this and have a look through across the plots. Okay, so 2019 we start. Peak is at 3:45 p.m. peak price, and the morning peak is 5:67 a.m. And we have a trough at 10, 11, 12 of 1 p.m. 10, 11, 12, 1 p.m. until 3 p.m. And I better throw in the caveat here that I'm a little bit unconfident that I could have made a mistake somewhere with time zones, etc. And also I think that these are the period starts. So if we look at, okay, we have the price of 71 euros. What does that refer to? Is it from 10 o'clock until 11, or is it from 9 o'clock until 10? I think it's 10 until 11, but I could actually be wrong about that. This really should have units, but I don't care. It's euros per megawatt hour. Okay. Let's flick through. So we have 2020, 2021. These all look quite different. 2022, 2023, and 2024. You know what we can kind of see is this evening peak moving later as the years go by. No, it's only in the last 2 years. So we have 3, 4, 5, from 5 p.m. until 6 p.m. during 2019, from 5 p.m. From 5 p.m. From 5 p.m. From 5 p.m. From 6 p.m. and from 7 p.m. Interesting. So could it be that there's enough solar PV in the system and maybe well charged batteries to soften that peak around 5 p.m. and 6 p.m., especially at 5 p.m. that during the summer, the sun is still well high in the sky. Okay, do we have anything comparable during the morning? My computer's getting kind of hot. Okay. Peak at 5, 6, 7 a.m. What's this? 8 until 8/9 equal 8, 7, 7, 7. Can't really make any conclusion from that. And now, how about this kind of dip? Okay. You know what? I kind of want to look at a distribution for this, and I want to see if are we starting to see it touch zero or near zero on certain days. So what if we did a histogram? So we're going to look at a histogram of this column instead of just looking at the mean. Let's see. So what we're going to look at is the rows which the hour is equal to 1 o'clock. One more little technical thing about solar for those who are wondering. Noon in Ireland is not solar noon, astronomical noon is not 12 o'clock. During the winter time, it is approximately 12:30 p.m. and during the summertime, it's approximately 1:30 p.m. So this time period from 1 until 2 is actually when the sun is the highest in the sky. And that explains why we're not looking at around 12, if you're wondering. Let's just do that and see. Oh, x must be numeric. Yeah. There we go. Oh, that's ugly. Okay, no, we should just call this 2024. And now let's look at a couple of other years. So what have we got here? We have typically between 50 and 100 euros. Yeah. What was the year that prices were about the same. Was it 2022? Whoa, that looks really different. No, that was not the year that the prices were about the same. Hmm. 2021, what have we got there? More of these extreme highs, kind of extreme. Fewer of the real lows. What if we look at the okay, so we hit zero. Okay. Let's see how many times this hit zero during 2024. Just once. How many times was it lower than 10? Just once? More than 40? Come on. My code has to be wrong. This price at 1 o'clock. You know, this isn't a very big sample. And also, as far as I know, the weather this year has not been very sunny in Ireland. But even still, less than 80? 17. Oops. Let's copy that and look at 2021. Less than 80. 25. It's about the same as this year. Okay, so I kind of have my conclusion personally. It seems to me that despite a gigawatt plus of solar, there is no sign of a collapse in daytime prices for electricity in Ireland yet. Now, to do a real much better, deeper analysis into this, I think look at the auction electricity bidding, day ahead bidding market. And wind also plays a big role in this. But basically, yeah, it seems like the market has not, it still has some runway. How much, I have no idea, before the prices start to collapse, even in the very middle of the day during the summer. So the downside for this is that this is not going to make an interesting blog post or anything like that. This alone, but I know that prices have definitely collapsed in Australia, I think, for certain periods due to this massive surplus of solar. Maybe California as well, or maybe not a massive surplus, massive generation at certain times, and at least some surplus. But hasn't hit Ireland so far as I can tell. Good news for the solar industry, I reckon. That's all for now.